Hello, welcome to the Computer Literacy 101 class. We're going to continue where we left off from the introduction and we're going to talk about hardware. We're going to start off with talking about hardware. But before we actually understand what each individual hardware component does, we need to understand how computers work as a whole. In this video, we're going to cover processing, input, storage, data, and we're going to save computer components for another video. So let's get started. So we're going to start off by learning what processing means. I pulled up the verb, and on the computing side, it said operate on parentheses computer data by means of a program. And that's kind of vague. It doesn't really help us understand a lot. So if we look at the verb for everyday use, it's official and established procedure. And that's something that rings a bell. So the official established procedure for processing information is with a CPU. And it takes data in and processes it and spits data out. This is one of our input-output features. And these are tiny microprocessors that have super small microscopic circuits that store zeros and ones. This is called binary, and we'll go into depth into it a little bit later on this video. But right now, we got to understand that there is a device inside our phones or our desktops that does processing, and it takes our input and processes it. So it takes account of everything that we do, and it has a value that it will store for us. Let's go on to the next slide. We're going to define input now. So one thing that did stand out for me is that it talks about energy or information entering a system. But we're mostly interested on information. Energy is a little bit more in regards to troubleshooting systems. And that's usually a layer 1 problem, and we'll talk about this in later courses, but not on this one. We're just interested in the basics. Verb, put data on a computer. And that's pretty much what we're doing. We're putting data inside a computer. That's our input operation. So whether it's a keyboard, or if you're touching a virtual keyboard or touching a button on your phone, you're not processing, but you're inputting data into that system. Input-output operations. This slide is a little bit heavy on reading, so just giving you guys a heads up. Input-output operations are processes of taking raw data and outputting them into useful data for people to use. So one big takeaway is taking raw data. What does that mean? It means every time you type a key on your keyboard or press a button on your screen, it holds a value. And that value is going to be a couple numbers. Those are electrical signals, and we'll go a little bit more in depth into that later. Input-output devices can be keyboards, touch capacitive screens that take raw data and convert it into something a computer can use, which is binary. And that data is processed into a format that can be recognized by humans. So the computer takes that information, and you usually have a program such as Photoshop or Word, Microsoft Word, that does its magic and processes it and makes a document, whether that document is a Word document or a picture or even a website. So now let's process that information that we just took in. Computer input. So that's a keyboard, microphone, or even touch capacitive screen. So that's raw data that the computer is taking, and it's converting it from something that we're familiar as people to binary. Once the computer takes that data, it processes it, whether we manipulate it or the computer manipulates that data itself. It processes that information and spits it out into an output, which would be a picture, a Word document, or even sound, such as an MP3 player. Let's talk about computer language. Binary is zeros and ones, and they represent electrical states on circuits on computer hardware. So 0 means off. 1, you guessed it, means on. These are the only two variables on the hardware that could be present. You either have an electron charge or you don't have an electron charge. That's how computers talk. And we'll talk about what that means later. We also have hexadecimal, which is a little bit more advanced. It's not representative of electron states. It's just a base integer. So it's a value representation of 0 to 9 in addition A to F. So you have 0 all the way to 9, and then you can also have values of A and F, which is 16 values. So we're going to talk about the electronic representation of data. So whenever a human presses a button, such as the K value on your keyboard, it's going to spit out information. So it's going to give you like a code. And let's say, this is not the code, but we're speaking in hypotheticals right now. It's 10110. So you have these semiconductors that store this information and process that binary information. So let's say this is a little semiconductor. This is like a little cell that holds electron charges. This would be 1, this would be 0, this would be 1, this would be 1, and I'm just going to add a 0 here. Let's pretend there's another cell that holds electrical charge. They wouldn't be placed like this, but this is the only art I had to represent that. So this is how it would be stored. And the computer would know that, hey, this is K. And it will represent the K on the screen. So this value would be translated. So let's start from number 1. We press the K on the keyboard and it sends an electrical signal of on, off, on, off. It processes that and we get the K value on our Word document. All right, let's talk about data format. Data format is the codes of binary that we choose to represent characters. So we'd have ASCII, and that's a standard of coding. So if you're North American or pretty much anywhere on the Western Hemisphere, that's what we're going to use. Unicode is a universal code. It's international, so that's where everybody else uses. But here, you're mostly going to find everything, whether it's your Cisco routers or pretty much Notepad, they're going to use this format. And I would highly recommend that you look these up. That way you kind of familiarize yourself. So this is a binary. So this is all off signals. And null means nothing. Let's go to something a little bit more familiar. The @sign. The @sign's binary code is off, on, off, 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 off. Kind of weird, huh? And that gives you the @sign. So every time you see the @sign, this is what your computer is seeing. And whenever you press the B key, your computer is processing an off signal, on signal, off, 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 on, and off. Pretty cool, huh? All right, so we made it through this video. We're just going to review everything that we talked about. So we talked about input-output operations. So the CPU gets the input from humans, and it spits it out into a format that the computer will display. So whether it's an MP3, a picture, a video, or a website, that's what we get. So this is the basics of processing. And if you guys have any questions or want to look at any other courses, you can go to velait.net/courses. Or you can follow me on fmtech_ on Twitter. And if you have any questions, feel free to ask any questions, and I'll try to answer them as best as I can. Alrighty, guys.